Hello learners, today we will study adjoint of matrices and inverse of a matrix. Adjoint of matrix. The adjoint of a square matrix A is equals to small a ij n into n is defined as the transpose of the matrix capital A ij n into n, where capital Aij is the cofactor of the element small iota j. Adjoint of the matrix A is denoted by ADJ-A. Example, find the adjoint of the matrix as given in the picture. Solution. First, we will evaluate the cofactor of every element, then we will transpose that matrix to find the transpose of matrix. As shown in the figure, this is how we will find the cofactor of every element and then the adjoint. Inverse of a matrix. If A and B are two square matrices of the same order such that AB equals to B, A equals to I is the unit matrix, then B is called the inverse of A, that is B is equals to A inverse and A is the inverse of B. Condition for a square matrix A to possess an inverse is that the matrix A is non-singular, that is determinant A is not equal to 0. If A is a square matrix and B is its inverse, then AB is equals to I. Taking determinant of both sides, AB equals to I, or A determinant B determinant equals to I. From this relation, it is clear that determinant A is not equal to 0, that is, the matrix A is non-singular. When A is invertible, then the inverse can be obtained by the formula given below. A inverse equals to adjoint A upon determinant A. Question. Find the inverse and the adjoint of the matrix as given in the figure. Solution. We have to find the inverse of this matrix. First, we will find all the cofactors individually and then the adjoint of a matrix. Since A is an upper triangular matrix, the determinant of A is the product of its diagonal entries. This, we have determinant A is equals to -1, which is a non-zero value and hence A is invertible. To find the inverse using the formula, we will first determine the cofactors A iota j of A we have. Then the adjoint matrix of A is, using the formula, we will obtain the matrix, inverse matrix as A inverse equals to adjoint A upon determinant A as given in the figure. Properties of inverse and adjoint of a matrix. Property 1. For a square matrix A of order n, A adjoint A is equals to adjoint A into A equals to determinant A into I, where I is the identity matrix of order n. Property 2. A square matrix A is invertible if and only if A is a non-singular matrix. So in this lecture, we have covered adjoint and inverse of a matrix. Thank you. See you in the next lecture.